The field of quantum processing is progressing tenaciously, outfitted with a performance that far surpasses that of our regular laptops. The super-advanced PCs of the future will solve exceptionally complex problems that have, until now, overwhelmed even the largest supercomputers. Indeed, Chinese scientists have now made another breakthrough in the advanced universe of qubits, and with the Zhongzi 3.0, they have introduced a quantum PC that even rivals Google's Willow. But what else can it do? How does the quantum PC work? And more importantly, how might high-performance computers change our everyday lives? To get a sense of how significant the difference between a quantum PC and a common home PC truly is, consider the following analogy. While a quantum PC is a supersonic jet racing across the sky at an insane speed, the device in front of us is a dusty dirigible that chugs comfortably through the air. This becomes even more striking when we consider the incredible power inherent in the Zhongzi 3.0. Chinese scientists have recently announced that their new quantum PC has solved a computational task that would take Frontier, the world's fastest supercomputer, more than 6.4 billion years to complete. How is that even possible? How can quantum PCs make even the most powerful computers of our time seem like weak snails? To grasp this, we first need to understand how our normal, everyday devices actually work. Our laptops, cell phones, smartwatches, and tablets all have one thing in common. They work with bits. These can only take two states, either a 1 or a 0. In today's computer processors, these two states are represented by power. Power on means 1, and power off means 0. Quantum PCs, on the other hand, rely on quantum bits, or qubits. Like classical bits, they can also take the state of 1 or 0. However, they have an extraordinary property that traditional bits lack. A qubit can exist in the state of 1 and 0 simultaneously, or theoretically in an infinite number of states in between. If we think of a classical bit as a coin that can show either heads or tails, a qubit is like a coin spinning rapidly in the air so that we cannot determine which side is currently facing up. As mentioned earlier, a qubit can assume an infinite number of states simultaneously. But even if we consider just two possible states, each additional qubit doubles the number of states that can be represented at the same time. For instance, 3 qubits can already represent 8 states simultaneously. With 300 qubits, the number of states that can be represented simultaneously is 2 superscript 3, a number greater than the number of particles in the universe. Additionally, qubits in a quantum PC can be quantum entangled. This means they are interconnected, so that when one qubit is brought into a particular state, the state of the other entangled qubits changes instantly, at a speed faster than light. This allows calculations in a quantum PC to be performed at superluminal speed. #### the new achievements of Google's Willow. Until recently, the Willow quantum chip, developed by Google Quantum AI, was considered the frontrunner in this emerging technology. Willow uses quantum processors with 105 superconducting quantum dots as qubits. Recently, Google's team achieved a significant breakthrough, reducing the error rate of a quantum PC below a critical threshold. Remarkably, while the number of qubits doubled, the error remained halved. Experts see this as a fundamental requirement for scaling future quantum PCs. Despite the great potential of qubits, they are still highly prone to errors. Often, measurement results are lost when multiple computational steps are performed in succession, rendering the outcomes useless. To address this, Google researchers implemented a method called surface code. This means that quantum information is no longer stored in a single qubit, but is distributed across multiple physical qubits. Together, these form a logical qubit, a processing unit that ensures essential data is preserved even if a single physical qubit makes a mistake. With this approach, the error rate of a quantum PC should decrease as more physical qubits are used for error correction. However, in practice, this was previously impossible because the physical qubits themselves were too error-prone. That has now changed. Willow's qubits can now maintain superpositions, allowing for reliable quantum computations. The super inconvenience of states is quite a bit longer than its ancestor, Sycamore. The blunders are stifled dramatically, and if the supposed distance of the surface code, which shows areas of strength for how aggravation must be for a mistake to slip through the cracks, is expanded by 2, the blunder pace of the consistent qubit is halved. Moreover, the quantum processor representing the future has currently utilized its numerical muscles and settled an undertaking in a short time that would take the ongoing best supercomputer 10 quintillion years. To be more exact, the assignment was arbitrary circuit testing, a quantum calculation that generates a progression of irregular numbers. In the process, the scientists perform haphazardly selected quantum gates or, in other words, quantum physical math tasks to place the qubits in a complicated setup. That is to put it somewhat simply for classical computers to mimic. Zhuangzi 3.0 is competing with Google's Willow. As briefly mentioned at the start, the Chinese superconducting quantum computer, Zhuangzi 3.0, has recently given it a shot and tackled a task that would take Frontier over 6.4 billion years. Under the direction of Zhanyapeng and equipped with 105 qubits, just like Willow, the Chinese researchers are confidently stating that Zhuangzi 3.0 is comparable to its American counterpart. Specifically, the quantum computer performed 32 patterns of arbitrary circuit testing with 83 qubits. In the process, the researchers were able to perform 1 million samples in a few hundred seconds, which was a significant improvement over the previous record set by Google's Sycamore. Yet, the degree to which Willow and Zhuangzi are in competition with one another is a completely different question. After all, the researchers set entirely different priorities in their experiments. Zhuangzi 3.0 focused on scaling by relying on arbitrary circuit sampling. It achieved nearly 100% fidelity and handled computational tasks that researchers said were 6 orders of magnitude more difficult to simulate than the earlier Sycamore tests. Willow, on the other hand, depends on error correction. With the logical qubits of the surface code achieving error rates of less than 0.15% per cycle, the development of the hardware limits of error correction for future-proof quantum calculations is differentiated here. Anyway, the Chinese team has already announced that they will also be introducing similar error correction techniques for their quantum computer in the coming months. How might quantum computers change our lives? Okay, as a matter of fact, the described performance of quantum computers has sounded rather theoretical so far. But what practical purposes do these wonder machines actually serve? After all, we are unlikely to be faced with mathematical problems in our daily lives that take billions or quadrillions of years to solve. So, what are quantum computers actually good for? Well, the somewhat sobering answer is, right now, for literally nothing. The reality is that these super-advanced computers are simply not yet sophisticated enough to play a major role in our daily lives. However, scientists are quite optimistic about the future when technological advancements will allow specialists to use supercomputing power to simulate particle interactions or their potential states. This could lead to unprecedented breakthroughs in drug development. While artificial intelligence is already developing at a rapid pace, quantum computers could help it take another massive leap forward. Meanwhile, intelligence agencies and the military also have a keen interest in quantum computers. After all, they could be used to break today's common encryption methods. Moreover, these computers could be used to develop revolutionary materials and even combat climate change. But that's not all. As things stand, we simply cannot yet predict the number of potential applications quantum computers will actually have. Some physicists even believe it is possible that this new technology will allow us to simulate all of nature's processes, literally all of them. From the beginning of the universe to the evolution of life, quantum computers might one day provide answers to some of humanity's greatest questions. However, there is still a long way to go before these computers can live up to their boundless hype. After all, there is a reason why quantum computers are not currently in our homes but rather in laboratories or data centers. To control and capture the moving particles of the qubits, they must be immobilized by cooling them almost to absolute zero, minus 273.15 degrees C. So, it's still anyone's guess whether and when we might all carry a quantum smartphone in our pockets one day. But who knows? When the first wall-size computers were introduced in the 1940s, no one would have imagined that these strange devices would one day transform our lives. And now, you can change your subscription status. Just click approve and subscribe now to never miss another video from us again. We'll see you soon.